Okay, here's a sample of a problem that asks us to graph the function, then state the domain and the range. So if we're going to write a graph, we want to know what this looks like. Now, let's not forget here that one of our major tools in helping find graphs is this one, y equals a square root of x minus h plus k. We know that the graph of the square root of x looks something like this, and we know that these things, oops, something like this, okay? And this point where the graph starts can shift according to h and k. K can shift it up or down, okay? So let's remember that. K goes up or down, and the h is going to shift it either left or right, depending on whether it's positive or negative. The a changes the shape of the graph, right? If a is greater than 2, the graph gets wider. If a is if a is greater than 1 is what I meant to say, it gets wider. If a is less than 1, it gets really contracted if this was the regular curve of root x. Okay, so this is an a greater than 1. It's taller and broader than our regular curve. If a is less than 1, if it's a fraction or a like 1/2 or a decimal less than 1, it'd be like this. Okay, so that's what h, k, and a all mean for us. So let's remember that. The other thing is that this really x minus 7 to the 1/2 power, I hope you see that that is the square root of x minus 7. So first thing off the bat is I know that this is my h. It's looking for a negative, and we have a negative, so h is 7. Now that means it shifts the graph over to the right 7 places. Okay, I hope you know that from past experience in that graphing curve. So what that means is if my regular graph of x equals square root of x would look like that, this whole thing is just going to be shifted over here to be the new graph in red here, and it's going to move over 7 places. Okay, so this would be 7 units of x, 1, 2, 3, 4, 5, 6, 7. Okay, so now that I got some graph paper here, let's try that. And actually, we can actually try a few x, y values once we're done with that. Okay, I know it's going to start at 7, 0, and I know it's going to curve up and to the right like that. And so remember in the regular graph of y equals root x, you can plug in a 1 for x and you'd get 1. But now I'm plugging in 1 and I would get 8 and 1. Okay, if I went 4 spots over, and I'm actually going to go off my grid here, if I went 4 spots over, okay, it would be up at 2. And if I kept going out towards 9, it would look like this. So maybe I didn't choose the best graph paper here, but that's what my graph would look like. Something like this. All right, you can try that by, let's plug in an x of 0. Oh, we can't get anything with 0. Gosh, that's 0 minus 7. I get a negative under the radical. I can't have 0. We'll talk about domain and range in a minute. In fact, one thing you should notice is that I can't get anything but a negative under the radical until I get all the way up to x equals 7 or greater. So let's try that. When x equals 7, 7 minus 7 is 0. Square root of 0 is 0. So here's my function, right? X minus 7. Plug in 7, I get a 0. Square root of 0 is 0. If I plug in 8, 8 minus 7 is 1. Square root of 1 is 1. So there's my 8 and 1 right there. Okay, let's keep going. I am going to keep adding a few points here. I'm actually going to go out 2 past 7. I'm going to go 9. So 9 minus 7 is 2. Square root of 2 is about 1.414. So this is 1.414. Yes, you can use a calculator to check that. But 9 minus 7 is 1.414. So at 9, I get 1.4. Oh, look, we're right there. All right, I think a next interesting point would be, I'm going to skip all the way out to x equals 11. And the reason I'm doing that is because I know that 11 minus 7 is 4. Okay, 11 minus 7 is 4. Square root of 4 is 2. So at this one, it gets to be 2. So 11 and 2 is my next point. Just off the graph, I'd go up 1 and 2, and it looks like we're headed right there. So now we know what the curve looks like. They ask about domain and range, and so I cannot have any x that is less than 7. Therefore, the domain is all real numbers such that x is greater than or equal to 7. Okay, as far as my range, okay, range is all possible y values. Okay, if I go all the way out to infinity, if I plug in x equals infinity minus 7, the square root of infinity would be infinity. It'll get there slow, right? This graph is going to go like this forever and ever and ever. Okay, so it will eventually get to infinity. It'll take a while, but there's no limit to how high y can be. Remember, the domain is all x values that will give you a function still. Anything outside of this will not give us a function. Okay, the range is all possible values of y. Okay, can y be anything less than 0? No, we cannot get anything negative out of a radical as long as it is a even numbered radical. That's different if it's cube root or fifth root, but for the range, we are going to get all real numbers greater than 0. Oops, can't write, but anyway, all real numbers such that y is greater than or equal to 0. When x is 0, y is 0, so it does include this point. It does include it, okay? And y can be anything as long as it is a real number greater than or equal to 0. So there's my domain and range.